everyone, my name is Dream, and today I will gonna talk about the death of the space. Let's do it.
Looking up at the night sky,
Looking up at the night sky, we are amazed by how it seems to go forever. But what will the sky look like billion years from now? A particular type of scientist called cosmologist spend her time thinking about that very question. The end of the universe is intimately linked to what the universe contains over 100 years ago. And Einstein developed the theory of general relativity, a form of equation that help us understand the relationship between what a universe is made from and its shape. It turns out that the universe is made of and its shape. It turned out the universe could be a curve like a ball or a sphere. We call this positivity curve or cause. Or it could be shaped like a saddle. We call this negatively curved or open. Or this could be flat. And that shape determines how the universe will live and die. We know how the universe is very close to flat. However, the components of the universe can still affect its eventual fate. We can predict how the universe would change with time if we measure the amount of energy densities of various components and in the universe today. So what is the universe made of? The universe contains all things that we can see, like star, gas, and planets. We call these things ordinary baryonic matter. Um, Even though we see them all around us, the total energy densities of these components is actually very small, around 5% of the total energy from of the universe. So let's talk about what the other 95% is. Just under 27% rest of the energy density of the universe is made of what we call dark matter. Dark matter. Dark matter is only very weakly interacting with light, which means it doesn't shine or reflect light in the way that stars and planets do. But in every other way, it behaves like ordinary matter. It attracts things gravitationally. In fact, we the only way we can detect this dark matter this through is through gravitational interaction, how things about um, eh, how things orbit around it and how it bends light as it curves the space around it. We have yet to discover a dark matter particle, but scientists all over the world are searching for this exclusive particle or particles and the effects of dark matters on the universe, but this still doesn't add up to 100%. The remaining 68% of the energy density of the universe is made of dark energy, which is even more like anti-gravity force. We say that it has a gravitational pressure, which ordinarily make matter and dark no matter do not. Instead of pulling the universe together, as we would expect gravity to do, the universe appears to be expanding apart at an ever increased rate. The leading idea for dark energy is that it is a cosmological constant. That means it has the strange property that it expands as the volume of space increase to keep its energy density constant. So as the universe expands, as it is doing right now, there will be more dark energy. Um, dark matter and bionic matter. On the on the other hand, and on the other hand, don't expand with the universe and becomes more diluted. Because of this property of the cosmological constants, the future universe will be more and more dominated by dark energy, becoming colder and colder. And expanding faster and faster. Eventually, the universe will run out of gas to form stars, and the stars themselves will run out of fuel and burn out, leaving the universe with only black holes in it. Given enough time, even these black holes will evaporate, leaving a universe that is completely cold and empty. Empty. That is what we call the heat death of the universe. While it might sound depressing living in a universe that will end its lifetime cold and devoid of life, the end fate of our universe actually has a beautiful symmetry to its hot, fiery beginning. We call them accelerating and end states of the universe, a dust phase. The name of after the Dutch mathematician Willem de Sitter. However, we also believe the universe has another plan, uh, that the universe has another phase of de Sitter expansion. In the earliest time of its life, we call this early period inflation, where shortly after Big Bang, yeah, you know Big Bang, the universe expands extremely fast for a brief period, so the universe will end in much the same state as it began accelerating. We live in an extraordinary time in the life of the universe, where we can start to understand the universe journey and view a history that plays itself out in the sky for all of us to see. Thank you for listening. Bye bye.